All right, this is Ronald Shaw with FTT 122-54338, January 19th, 2025. On week 6 assignment. So we have some definitions and everyday examples of those definitions. The first one is trajectory and sights. Sights and optics are designed to create a line of sight. When sights are aligned with the target, the barrel is being pointed at a slightly positive angle. So for this, the example that I used would be throwing a baseball from outfield. So when you're trying to throw a baseball from the outfield to the infield, you have to have a slight positive angle, or else that baseball is going to fall short of your target there. Going on to the next definition is the gyroscopic drift. With a projectile that is being pulled to Earth by gravity, the force causes the projectile with a clockwise rotation to drift right. So that clockwise rotation is going to be from the shooter's perspective. My example on this one is the throwing of a frisbee. So if you throw a frisbee right-handed, that'll cause the frisbee to rotate clockwise and it will drift to the right. If you throw it left-handed, it'll have a counterclockwise rotation and will drift to the left. Moving on to the next one is drag. Drag is basically the deceleration of the projectile. For this one, the example that I would use is a drag car pulling its parachute. The drag car launches off the line at however many miles per hour, reaching its destination. Obviously, it's moving too fast, so it will pull its parachute to decelerate the car, causing drag. The next definition is the Magnus effect. This one is the spinning objects moving through fluids with flows perpendicular to their rotational axis, meaning crosswinds. And as I read more further into the definition, it dropped the fluids part. So the example that I have on this one here is that of throwing a football with a perfect spiral in a stadium. So with bad crosswinds, the stadium that comes to mind is the old Heinz Pittsburgh Steelers stadium. So a perfect spiral clockwise from the shooter's perspective with a right hand wind, so that's going to cause the football to lift, whereas the spiral with a clockwise rotation with a left hand wind will cause the football to drop. The Coriolis and Eötvös effects. The Coriolis affects the horizontal plane and the Eötvös affects the vertical plane. So in the Coriolis effect, it will always deflect to the right in the northern hemisphere. Doesn't matter if it's shot from the south to the north or the north to the south, it'll always deflect to the right. And it is the opposite in the southern hemisphere. So in the southern hemisphere, it doesn't matter if you shoot to the north from the south or south to the north, or vice versa, it'll deflect to the left. The Eötvös effect is when fired west, the projectile rises, and when fired east, the projectile falls. For that one, I couldn't come up with any example that was coming to mind to demonstrate that in an everyday instance. Moving to vertical angles, this refers to shooting uphill or downhill and using an incorrect estimate for distance. My example on this one's a personal example of archery hunting from a tree stand. I have never had good luck in the shooting downward towards the buck or doe of choice. That has always hindered me, and now I kind of understand why. So maybe I can correct that in the future. The last definition was the transonic ballistic performance. So this is the shock waves created by the bullet are unstable in the transonic speed, and that upsets the bullet's flight. So the example I had for this one was a wiffle ball. When you throw a wiffle ball too hard, it becomes disrupted, and the flight pattern is erratic. So that was what came to mind for the everyday example for a transonic ballistic performance.